All right, let's do our first problem. Volume by shell. So we're going to look at this. A sine bowl. Okay. So we're going to let R be the region bounded by the graph of f of x, which is equal to sine of the quantity of x squared. That's not sine squared of x. That's sine of x squared. The x-axis and the vertical line, the square root of pi over 2. Find the volume of the solid generated when R is revolved about the y-axis. Now, I want you to keep thinking about these because while we do our homework, we know, like I'm doing the shell method. On exams, I most likely will not tell you to use the shell method, the disk method. I'll just tell you like, hey, here's a function, go about this axis. And then you're going to have your choice as to how you do it. So maybe start thinking about it, like which one do you prefer? Which one do you like? Sometimes one is easier than the other. Sometimes one makes things, oh man, much, much tougher. So it's going to be up to you to try and figure out when it's applicable and when it's not. Enough of that. Let's just get into a problem. So let's see the pictures. So on the left, we see that we have some function. And then we have this area, right? It's trapped above the x-axis. And now it's going to get revolved around. So the height is equal to sine of x squared. But that's our f of x. And then we're going to say that the radius, right? It talks about the radius right here is just x. So this actually isn't that bad. This isn't that bad. So the shell circumference is 2 pi x. And the shell height is sine of x squared. Let's see if we can't solve this problem. So what do we have? The volume is equal to 2 pi times the integral from a to b of x times f of x dx. So we've seen the picture, but I know for myself, I'm not drawing the gosh darn picture. I'm just looking like, hey, everything's in terms of x's. We're going about the y-axis. We're using the shell method. Let's go. This is the formula we must have memorized. So it tells us our f of x is equal to sine of x squared. Our a is 0, and our b is square root of pi over 2. So let's do our problem. It's 2 pi. So we're going from 0 up to the square root of pi over 2. X is always there. We don't have to solve for x. X is just x. And then f of x is going to be our sine of x squared dx. Let's go. Let's go. So now we have to solve this integral. Good thing we learned how to do. Oh man, good thing we know our u subs, huh? So we're going to say u is equal to x squared. And our du is going to be equal to 2x dx. We divide out our 2. There we be. There we be. So now we can get everything in terms of u, and we won't ever have to go back. We won't ever have to go back into terms of x's because we have bounds. So we're going to replace our x squared with a u, and then we need to replace our x dx. And that's 1/2 du. So I'm going to put the 1/2 out front and then put the du right here. Hey, let's go. That's not bad. That's not bad at all. So let's see what we have. So if x is equal to the square root of pi over 2, then u is equal to its squared, so that's just pi over 2. Oh, cool. And when x is equal to 0, we got to square that up, and 0 squared is just 0, so we're going from 0 to pi over 2. Hey, this ain't bad at all. It's not bad at all, sorry. I must get better with my English, you know. So let's go. We're going to say the volume is equal to pi times the antiderivative of sine, which is negative cosine of u. And we're going to evaluate it from 0 to pi over 2. Oh, shoot, are we going to get a negative volume? If we got a negative volume, then maybe something's gone horribly wrong. I think math might be broken. It's not broken. We're okay. So it's negative cosine of pi over 2 minus negative cosine of 0. So we get pi times, well, cosine of pi over 2 is 0. Any odd multiple of pi over 2 plugged into cosine is 0. plus cosine of 0, which is 1. Oh, the answer is just pi. So once again, it's not that bad. Once you have it down, just little tricks. You don't have to draw too many pictures with this either. It's fairly straightforward. You're like, it's just 2 pi x times the f of x times whatever the function was that was given to us, and we need to make sure that we put in our bounds. Don't forget to multiply by 2 pi because we're doing the shell method. And once again, the way we're going to know which way to go when you're not just doing homework in this section is you're like, hey, everything's in terms of x's and I'm going about the y-axis. Or everything's in terms of y's and we have to go about the x-axis. That's telling us shells. Shells. Because I highly doubt you want to try and take this and be like, well, let's find its inverse so I can go through and do this with discs. Yeah, good luck with that. Tell me how that works out, huh? You're going to end up with a square root of sine inverse? You don't have the techniques yet to be able to solve it, so you're forced into this. Shoot, if you learned all your integration techniques beforehand, you could do this pretty quick. All right. I'll see you in the next.